Good afternoon, everyone. My name is Dave Amato, and I want to thank you, everyone, for joining us today to learn a little bit about DDI design. We're lucky to have Brian Toombs with Burgess and Knightful as our presenter today. Brian's a national expert on DDI design and has been involved in dozens of DDI projects across the country. And we are lucky to have him as support for our review efforts on DDIs in the structures design, in the roadway design office. With that, I'll give it over to Brian.
Terrific, thank you, David. Well, good afternoon, everyone. Welcome to the Florida DOT DDI Design Webinar Series. This is the first of several webinars that we are putting on that are focusing on diverging diamond interchanges, or DDIs. So just give you a quick little update on where we're at. This series is intended to present guidance on the major elements of DDIs, including geometric design, signing and pavement markings, traffic operations, signalization, plan detailing, multimodal accommodations, public involvement. The schedule you see down there are these more focused, targeted DDI webinars that are going to focus on specific topics. This first one today is just the overview. So this is going to give us a kind of a good indication of what a DDI is, as well as what are the benefits, the safety, and then we're going to touch on these other specific areas. But on those that have a specific hour-long webinar later in the calendar year, we won't hit them quite as hard. For those that have been getting involved in DDI design, Florida DOT has developed design criteria, Ddi 217, which is basically the guidance that Florida DOT is putting together for how to design and implement diverging diamond interchanges. So we're going to touch on that a little bit as well today, as well as what Florida DOT has done adopting the diverging diamond interchange. So this webinar series is intended for transportation professionals that are involved in the planning, design, and review of DDIs. So hopefully you find this to be interesting and valuable. When you see the schedule down here, there is one change that we made, I think, yesterday. The multimodal accommodations one that you see, the second to last one, is set for August 24th. What was previously there was a DDI plans detailing, but we have since decided to combine the plan detailing and the public involvement into one webinar on September 7th, and then create a new webinar for multimodal accommodations. That's on August 24th. Hopefully you guys have seen that revision. If not, please let us know and we will make sure that you get that revision so that hopefully you can attend that. So you heard David Amato, he's the one who introduced me. He is the Florida DOT roadway design engineer. He is responsible for a lot of the reviews of the DDIs, and he has developed the Ddi 217 criteria for DDIs. And then myself, there's my contact information, Brian Toombs with Burgess and Knightful. I've had the privilege, benefit of working on several dozen DDIs, either in conceptual or in planning or preliminary engineering, design, or even reviews. So I hopefully bring a lot of good information, but certainly, it's not the end all. And if you have other questions, by all means, don't hesitate to ask. So we talk about the webinar logistics quickly. Hopefully you were muted upon entry. I think you were. And because you're muted, you don't have the ability of pressing unmute and asking questions. So please use the questions dialog box that's part of your web or your dashboard. So, and this screen kind of walks you through a little bit about how you would do that. David will be monitoring the questions. Feel free to ask questions at any point during the webinar, and hopefully we can get to them as we go. We do have a lot of information to cover. So if we're not able to answer your questions, we will address them as soon as we can after the webinar. And as a quick reminder, this webinar is being recorded. so that hopefully you guys can refer back to it if you need to. So today's webinar agenda, we're first going to touch on what a DDI is. Then we're going to hit the benefits of a DDI and when it should be considered. We're going to touch on Florida DOT's DDI adoption. Then we're going to get into the key Ddi development features. And then somewhere in there, we're going to take a break because 3 hours is a long time to listen to anybody speak. And then we're going to finish up with the Ddi development features and then talk about the additional Ddi resources. So with that, let's get started. So first, let's focus on what is a DDI. And hopefully for a lot of you, this is going to be fairly beginner, but I think it's still very important to remember what we're talking about here. So diverging diamond interchange. It's an interchange that allows for two directions of traffic on the crossroad to temporarily divide and cross to the opposite side to gain access to and from the freeway more easily. So when we say that, traffic crosses over to the left side of the roadway between the ramp nodes of the interchange. One thing I do want to stress, it's very easy when you're talking about this to the public to say that traffic crosses over to the wrong side of the road. Please don't say that when you're talking to the public. Those type of words, they tend to gravitate towards. Try to say left side, left side, left side. So if you catch me saying wrong side, please yell at me because that is something that I've been trying to beat myself out of as well. And this eliminates the need for left turn signal phasing. With no opposing traffic for the left turning movements at the interchange because now they can do a free flow and slip onto the entrance ramps. So really adds a lot of capacity improvements that we'll talk about as well as safety improvements. So this just very high schematic level talks about what a DDI is. So you'll see the blue would be one phase of operation. Red would be the other. A couple things you'll notice with a DDI is, say, if you're tracking from left to right or eastbound in this drawing, the eastbound through at the first or the left-hand crossover intersection can be run at the same time as the southbound right turn from the ramp. And conversely, the westbound through, which is blue, can be run at the same time as the left turn from the southbound ramp. Those are the benefits that a traditional diamond won't be able to allow. Having a left turn and a through movement go at the same time. So that's where, like I said, we're going to touch on. These are the benefits of that DDI. So when we talk about the benefits, the first one is that better traffic operations. We're seeing a reduction in intersection delay, and it eliminates the need for that left turn signal phase. So that's truly going to allow for better operations at that signal. From a lower cost standpoint, a lot of times we can utilize the existing bridge with a diverging diamond interchange because we don't need as many lanes. We don't need those dedicated left turn lanes that typically can widen a bridge. We also don't necessarily need that approach work as they approach the bridge because, again, we're not having to flare the through lanes out to accommodate those dual left turn lanes potentially in each direction where you could have a very wide cross section across that bridge and the approach pavement leading up to it. And from a safety standpoint, much fewer conflict points for both vehicles and pedestrians with a diverging diamond interchange. And typically what we see is lower travel speeds. We introduce curvature at a DDI to slow drivers down as they approach these crossover intersections. Whereas at a traditional diamond, which your traditional intersection, light's green, traffic's going however fast they're able to go. And if the light turns yellow, a lot of times people are still gunning it to get through that light as fast as they can. So speeds are usually a lot higher, and when we have crashes at a traditional diamond, say a left turn trying to hit a gap, can be very catastrophic. So these are some of those benefits from a safety standpoint that we'll touch on. So we talk about this, traffic operations. Let's focus on the signals, okay? So your basic two-phase signal operation, this is an example right here. The left pie chart would be, a minor road in that green cross hatching has a certain amount of the entire traffic cycle, which is green. But you'll notice how big the other green section is, which would be the major road or the arterial or whatever. A little bit of clearance interval, a little bit of all red potentially showing up in this thing. But this is a pretty good breakdown of how much green time you can expect with a two-phase signal. So as we look at this, when we add left turns, left turn phases, like a traditional diamond, what happens? You lose a lot of green time for those through movements. Again, this is a traditional diamond interchange. You know, you go from what you see in the upper right, where it's two phases, a lot of green time for phase one, let's say, a decent amount of green time for phase two. Look how much shorter it is now for phase one, two, and three in the setting below. And if we continue to add traffic phases, we continue to steal time away from the major through movement and stealing that green time. So if you look at the left-hand circle, you know, that's that two-phase signal. Look at all the green time for what would be the north-south movement in this configuration. Go to the three-phase, and if you go to that four-phase signal on the right-hand side, look how much smaller that green time is for the major route. Additionally, look how much time we have now added to this cycle for clearance intervals, that lost time of the signal where the signal is really dead. It's the all red time, it's that yellow time where traffic is, you know, it's not really moving traffic. There's a lot more of that when we add phases. The other issue you can run into with a diamond interchange is what they call demand starvation. So this image shows it pretty well. The eastbound or the left to right movement, green, they're going through, it's pretty full. The western intersection is green for the westbound direction as well. But because we've operated a left turn phase on the east intersection, traffic is stopped. So there's actually no traffic that's using that westbound left-hand intersection. So it's green with nobody going through it. And that's a problem. Again, when we talk about the efficiency of that signal, it just got significantly reduced. So if we look at our traditional diamond, we look at the signalization here. First phase, through movements only. And this is an example, but it usually is pretty good one. Notice the ramp traffic is stopped. Second phase, the ramp releases. So now both the through movements are stopped. Then third phase, left turns, and you know, one of the through movements is going, but the eastbound in this case through movement is stopped. So it's chunked up and not a lot of green time, especially for that westbound movement or the ramp movement, because of that left turn phase that was added in there. Now, here's how a DDI operates. Again, with the traffic moving to the left side of the roadway, we are able to create these two-phase signals at each of the two crossovers. So when we do that, we have a couple of different phasing strategies that we can do. So on the left-hand side, we are allowing progression for the crossroad. So, you know, one direction's moving, then the other direction's moving. And you can time it to where the direction, you know, say the westbound direction gets a green light at the first crossover intersection on the right side, continues through the interchange core and gets a green light by the time it gets to the second crossover and goes through. So in this case, really that direction would only stop one time. It could be the same for the other direction if we open it up phase two. The other option for a phasing strategy is what you see on the right side, which is allowing, say, the left turns from the exit ramps to work their way through the interchange. Again, the goal would be having them stop only once. So what you see in phase one, that southbound left turn comes through the intersection and it faces a green light at his first traffic light, which is the right-hand crossover. And subsequently could be done the other way. So those are the different strategies that we could implement, and that's going to depend a lot of times on your volumes. Which is the heaviest movement through the interchange? What are we trying to prefer? So now let's think about cost. So, well, DDIs we've talked about are lower cost, but why is that? Well, what's typically the main cost contributor to an interchange project? You're looking at it, it's the bridge. So this is an example of a traditional diamond interchange, and you'll notice that that bridge is 8 lanes wide, which is 2 lanes in each direction, plus back-to-back dual left turn, or side-by-side dual left turn lanes. So it's an 8-lane cross section, which is a lot of bridge deck. It's also a lot of approach work on each side because you've got to line the through lanes up and you've got to get them around the left turn lanes. Notice the amount of curbing that you have in the middle on the approaches, amount of concrete work because you've got to offset the left turn lanes. So all of that starts to really impact, the cost from a pavement standpoint, from a width standpoint, that sort of thing. And that bridge becomes very expensive. So with a DDI, you can kind of see it in the bottom right corner, the increased capacity of the unique configuration provides the potential to reduce the number of lanes, which often reduces the right-of-way needed for the interchange when compared to the diamond. And this right-of-way reduction is not just within the interchange itself, but on those approaches. And the reduction in the number of lanes gives us a smaller bridge footprint. So let's show you a couple examples. And this is a real example that we did. And this was a fairly similar project that we've done in other places. So we looked to improve an interchange, and we said, all right, first let's look at a traditional diamond. This traditional diamond had dual left turn lanes, but across the bridge, we were able to get it down to a single left turn lane that then opened up just off the bridge to dual lefts. But even with this, it still required a 6-lane bridge cross section. Same location, same volumes. A DDI through here, we were able to do 2 lanes in each direction because with the free flow left turns, they didn't have to be created on the bridge. They could be created off the bridge with just that short deceleration length before they hit their curves. And as a result of that, we had a 4-lane bridge. So that's a significant savings right there. Most of the time, what we end up seeing is when you get to alternatives that are leveling to the point of a diverging diamond interchange, we oftentimes see dual lefts across the bridges as well. And what we end up seeing is usually an 8-lane bridge versus a 4-lane bridge for a DDI. And here's another good example. So here we have an existing grade separation. This is along I-75. It's a 2-lane bridge over the freeway. 1 lane each direction is all it is. But significant development is going to happen at this location, so we want to put an interchange at here. So with the diamond interchange, there's your bridge. It is a 6-lane bridge, 2 lanes each direction plus back-to-back, or I should say side-by-side left turn lanes to handle the turning volume at the interchange ramps. Now, diverging diamond interchange, same location, same traffic volumes. One thing I want to point out, it's a 2-lane bridge there on the north side, but notice, we can utilize the existing bridge here. So this cost savings went from a 6-lane brand new bridge because we couldn't take the existing 2-lane bridge and widen it because widening it with the cross slope that we had on that bridge was actually reducing the vertical clearance too much. So we would have had to raise that bridge anyway, so it required a new bridge. So a 6-lane bridge in the diamond to a 2-lane bridge on the DDI because we're utilizing the existing bridge. Later we'll get into pedestrian accommodations, but this also gives you an opportunity to keep the existing bridge the way you have it, put the other lanes and the pedestrian accommodations on the new bridge. So as opposed to even touching the old bridge. So there is a significant cost savings with implementing a DDI, even at a location where there's not an interchange at all. So one of the things that we used to hear a lot when we first started talking about diverging diamond interchanges were these early concerns that people had, these safety concerns, right? So, will the DDI cause driver confusion? Will the DDI cause head-on collisions? Because they're looking at this unique, innovative alignment, and they're worried about drivers colliding into each other. Will it create wrong way movements? That's something we hear all the time. And that's why the other reason why I always try to avoid saying on the wrong side of the road, but instead I say the left side of the road when they're in the interchange core. Will it cause pedestrian confusion? Which is a legitimate question. And those we'll be talking about here later in this webinar. Will it be difficult for bicyclists to navigate? Another question that we hear a lot is this something that a bicyclist can understand and ride through? We'll touch on that. And will it delay emergency vehicles? If it's confusing for the drivers, and maybe we got less lanes now because of the improvement or the efficiency of the signals, will the emergency vehicles even be able to get through it now? And then another one that I always love to hear is, will it work when the power is out? And that challenge there is, well, does a regular signal work when the power is out? It goes to essentially what? Also always stop. So would a DDI function if it went to an always stop as well? So these are those safety and even operational concerns that we've heard, that we've seen. David,
Hey,
looks like you got a
Brian.
couple questions. Yeah, David, go ahead.
Yeah, I was going to ask you. There's a question about comparing a DDI to a single point urban interchange or a SPUI.
Yeah, I don't think I could see the question. Are you able to?
Okay, I'll read it. Can you please speak in terms of a single point? A traditional diamond doesn't compare only because the FDDI would traditionally be the desired type, not the compressed or the spread diamond.
Yep. So they're asking, I think the question was, your mic broke up a little bit, but it sounded like you were asking, or they're asking, compare it to a single point, not just a diamond?
Right.
Yeah, so, I mean, that's a great question, because certainly, the DDI is not the end all. There are certainly other interchange configurations that you could and should be looking at. I will tell you a single point definitely has advantages, especially when you have very closely spaced adjacent intersections. Because a single point obviously coming together as a single intersection, essentially in the middle of the freeway, if you will, but up elevated or lower. But the single point comes with its own challenges, being usually it's a very large bridge structure if it's on top, or it's a very large span if it's a freeway that's over top of the arterial. So it's potentially, there's some sightline issues if the single point is below, especially when you're looking at traffic lights or traffic signals. You also, a lot of times single points work really well when you have balanced movements. In other words, if you have the left turns off the freeway that are fairly similar in both directions, those work well because those two are going at the same time. However, if you've got one very heavy, say southbound to eastbound left, but the northbound to westbound left is not that heavy, then you end up with that loss of efficiency where you're having to drive the signal timing based on that heavier movement all the time. So those are part of the things I know. Florida has an ICE policy in place. Those type of interchanges should still be evaluated. I can honestly tell you, in most of the times when I evaluate a DDI versus a single point, the DDI typically comes out ahead because of cost and right-of-way impacts. And usually we see a little bit more latent capacity out of a DDI than we do out of a single point. Single point hits that threshold of capacity a little quicker. Dave, you got any more questions? Oh, actually we do.
Well, this all has to do with the single point.
Okay.
It says, however, the DDI needs considerable more right-of-way that could exceed
Yeah, it looks like what they're saying is they believe the single point would fit in a much smaller footprint, and I assume you're referring to potentially the approach because the DDI has that bulbous nature, if you will, what I call kind of that Q-tip outside of the bridge.
Right.
And while that's true, remember that typically a single point stacks left turn lanes, on the bridge, right? So you've got oftentimes a dual left turn lane in each direction. So now you're back to that 6-lane bridge or greater, or 8-lane bridge. Remember that your width on the outside, those through lanes have to flare out to accommodate the left turn lanes. So you end up with a little bit wider footprint. But yeah, it's definitely one of those things you definitely would want to evaluate. So it's great. It's a great question, a great point. The next question in your DDI example were right turns signalized. And the one that we looked at, yes, and I'll get into that a little bit. I recommend signalizing the right turns almost always. With it being only a 2-phase signal, you're really not losing a lot of green time efficiency. And so signalizing the right turns, and we'll touch on a little bit about what the benefit is to those, both from a sight line, from a driver expectancy, as well as from a pedestrian accommodation. So, but yeah, so in my example, the right turns were signalized. All right, so those are good questions, and thank you for asking those and continuing to ask those throughout this presentation. All right, so as we keep going, just a second, make sure, here we go. So we talk about the improved safety of a DDI versus a conventional diamond, and I do apologize. I am comparing this to a conventional diamond most of the time because that's typically where, in the past, our brains have always started. We take the conventional diamond is your most common interchange configuration in the country for a reason, because it's typically that's one of the easier ones, if you will. But with a conventional diamond, you're looking at 26 total conflict points, but big time 10 crossing conflicts. Those are the most severe. Those what lead to oftentimes the most severe crashes. So those would be, vehicles left turns trying to cut gaps and potentially crossing a opposing through, which can be challenging certainly to navigate, especially drivers that maybe can't perceive the gaps as well, or older drivers, or whatever that case is. You tend to see a lot of those really catastrophic crashes as a result of these crossing conflicts. Conventional diamond, there's 10. With a DDI, there's 2, and it's just at the crossovers. And so really what we need to be targeting when we talk about the geometric design of those of the DDI, it's those crossover intersections. What can we do to minimize that, those 2 crossing conflicts, and then you see only 14 total conflict points. So, a much better from a safety standpoint, a DDI versus a conventional diamond. Now, you remember one of the concerns about safety is does it promote wrong way movements? So I always like to use this example. This on screen here, the image that you see is a traditional diamond interchange, okay? And you'll notice that the ramp that comes from the bottom is a exit ramp from the freeway that's coming up to the arterial. So if I'm eastbound on the arterial and I make a 90-degree turn right there, which is pretty easy to do, I could potentially be going down the freeway in the wrong direction. So that's a real problem. And there's not a whole lot that's discouraging you from doing that if there's not traffic sitting there. Obviously, if there's traffic sitting there, that's good in that respect. Same general strategy here for an interchange or for a DDI, where you've got that exit ramp from the freeway as the ramp's coming from the bottom. To make that wrong way maneuver is about usually it's greater than 140 degrees. So while it can still be done, it's not quite as intuitive to a driver to make that wrong maneuver. And part of what we're always trying to do is we want to make it a forgiving highway. We can't, I always use the phrase, we can't design for stupid, but we can certainly try to, accommodate drivers who are making decent choices to not make a bad choice in this particular case. So a diverging diamond interchange is a good option in that respect. So those are some of our guts about what we believe the safety benefit is to as a DDI over a traditional diamond. FHWA in 2015 did an evaluation of 7 of the earliest DDI conversions in the United States. And I want to stress, these were the first ones, essentially, the first 7 DDIs in the country. 4 of them were in Missouri, 1 was in Kentucky, 1 was in Tennessee, and 1 was in New York. And what they did, FHWA did, is they collected 4 years of before and 3 years of after crash data at these locations. And what they learned is that implementing a DDI in these 7 cases based on this data gave us a CMF of total crashes of 0.68 and of injury and fatal crashes of 0.61. What that means is that they expect to see a reduction of injury and fatal crashes of 39% by implementing a DDI over a traditional diamond interchange. That's massive when we talk about safety benefit. And I wanted to stress again, these were the earliest DDI conversions. We've learned a lot about DDIs since these were even implemented. We've learned about some of the geometric configurations that we need to be focusing on. We've learned about what drivers are tending to do and we've learned to accommodate them. So if we were to run the same evaluation on some of the DDIs that were just constructed 3 years ago, I think we'd see even better numbers. So Missouri DOT did an evaluation study in 2015 where they evaluated 6 of their early implementations. And they compared those to 6 diamond interchanges. And again, similar process. They collected 2.5 years of before, 2.5 years of after DDI conversion. They didn't account for the crash data that was done or that was collected during the construction. They threw that out. And what they were seeing was significant benefits as well. Reduction of total crashes of over 40%. And in their particular examples, a reduction in injury and fatal crashes of over 60%. Again, from a safety standpoint, significant crash reduction benefits over the conventional diamond interchange. So, I mean, those speak volumes right there. There is CMFs out now for a DDI. So, those are been researched and have been tested and will continue to be. All right, so when should we consider a DDI? And I always love to ask this question. DDIs are a one-size-fits-all solution that work everywhere. Is that true or false? And I will tell you, I am a DDI guy. I would love to put DDIs in about most places, but I also recognize that they are not a one-size-fit-all. And there is a time and a place for a DDI, and there are a time and place when a DDI is not the right solution. So we'll talk a little bit about that. So when is it a good alternative? When it's a retrofit of an existing interchange. Because typically what we see is, that improved operation, that improved safety without needing to replace the existing bridge structure. So the 2 images you see on the right side, it's the exact same interchange, obviously taken about 12 years apart or 8 years apart. The first image on the top right is the diamond interchange. Bottom right is the DDI. The bridges are the exact same in both these alternatives. Now, obviously the pavement outside the bridges are different. So it kind of goes back a little bit to the one question that there was concern about the right-of-way impacts. When you look at the right-of-way impact of the, of a diamond versus even like a single point, one thing you'll notice is this is fairly compacted. In other words, the upper right corner of the bottom image, that free flow movement, that right turn, which would be west to north in this image, is the exact same ramp as the upper right image, or the upper right image, west or north. It's the same ramp. So you can kind of see that we didn't bulb out over there. And then, in a couple of the other locations, we bulbed out a little bit, but it does get a little bit fatter. But again, is the pavement benefit on the approach, is it offset by the savings from the bridge? So that's a huge benefit, though, when we talk about retrofitting it to improve the existing interchanges. And when we have a new interchange with high left turn volumes, so this is where, again, you start looking at whether a single point or a DDI works better. It comes down oftentimes to, again, the number of lanes. So both can handle very high left turn volumes, a single point and a DDI, but a DDI typically requires less lanes to do it. Again, we talk about that latent capacity, that available capacity that's not even, that we could still add 10% more or 15% more capacity and still get a DDI to work, that type of thing. In the high ranges of traffic capacity, depending on the number of lanes included, we can expand a DDI to 3 lanes each direction and get a lot of traffic through it. So along those lines, we talk about DDIs in all sizes. So, they go from a single lane DDI in Cheyenne, Wyoming. So this is at I-25 and College Drive. Notice it's 1 lane each direction across that bridge. Now they've got extra width because of a sidewalk in the middle, but it's still a pretty narrow bridge, relatively speaking. Interestingly enough, I don't know if you can see by the cross-hatching, they've actually got this thing phased. They have the ability of putting a second lane in that DDI. And so it's a, it's certainly something that you would do, but in this particular case, a single lane. Congratulations, Sarasota, Florida, you have the largest DDI in the country. The I-75 and State Route 93, 6 lanes in each direction. So this is a big cross section. And then you've got a 3-legged DDI in Maryland, where it's a crossover intersection on the one side, but the arterial terminates at the freeway. So, and I see we got a comment about the consideration is highly oversimplified, does not consider the operation of the arterial adjacent to the interchange that may or may not support the traffic flow in DDI itself. You're absolutely correct. That's a great point, and we will touch on that. When we're looking at a DDI and the traffic operations within the interchange, we need to be looking beyond the interchange. We need to be looking at the corridor itself. Because if you pop the plug at the interchange, you could potentially completely crush the adjacent intersections. And that's a great point that we definitely want to make sure. Remember that, Frank. We'll come back to that certainly when we get down a little farther in this webinar. So in general, DDIs are good when heavy left turn demands in comparison to crossroad through volume, or when their heavy crossroad through volume is greater in one direction, like left turns. So basically it's either or. Either the left turns are really high or the arterial is high, but it's really that one direction of arterial. And here's why. Because the problem with a DDI is, heavy opposing through movements on the crossroad don't work. And the reason for that is because we split phase the through movement on a DDI. So, a traditional diamond, when you're at a ramp terminal intersection, both directions on the arterial can run at the same time, both through directions on the arterial. On a DDI, we split phase it. So if we have heavy volume in both directions, so say in the PM peak, if eastbound direction requires more than 50% of the green time and the westbound direction requires more than 50% of the green time, guess what? We just broke a DDI. So, and then there's ways that we'd have to get around that. And to the point that we just were talking about, if we have closely spaced signalized intersections that are saturated, unable to be improved, that could be a problem as well. So, the overall corridor operations may not significantly improve even if we improve the interchange. And so it may not be a benefit to actually drop a DDI in this location. Remember what I said, I'm a DDI guy, but I recognize that there are limitations of when you can or should not use a DDI. And then constraints along the crossroad may not allow the construction of the crossover intersections. And so here's a good example of it. In this particular location, a point that was made earlier in one of the questions about that sometimes you get pretty fat on the approaches because of this, what I call that Q-tip look, where, at the crossovers. If there's a right-of-way or an environmental impact that's adjacent to the roadway, this may not be an option that can be done. In this example here, you see that little white line that runs parallel to the roadway. That's a retaining wall. We had to add a pretty substantial retaining wall in this project to stay out of a environmentally significant area. So those are the things that you certainly would want to be thinking about if you're looking to implement a DDI. And the other challenge that DDI presents is if you're on a heavy load permitted route, or if you have, those vehicles that are over height that need to utilize the exit ramp to get around the bridge. Let's say it's a arterial that goes over the bridge and they don't have enough vertical clearance, so the vehicle has to exit and then enter back on. Can't really do that in a DDI. As you can see by this image here, it does not allow the vehicle to cut through the crossover. So something to always be thinking about as well. All right, so let's talk a little bit about the Florida DOT DDI adoption. So Florida DOT first began designing DDI projects in 2011 with the advent of the 75 University Parkway project. This is in District 1. This is the massive DDI that you see on that screen, the largest one in the country. It was a conventional design bid build project with the design phase beginning in late 2011 and lasting around 4 years. So the construction was executed in the summer of 2015, and the facility was open to traffic in May of 2017. So, as you can see, it is a very large DDI, and it was the first one. So, you guys started with a bang. You didn't look at one of the smaller ones. You said, what is my biggest traffic nightmare, and what are we going to do? And I believe, if I remember correctly on this project, about 20 different ideas were thrown around about how to make this work. And this is what came up, and it works very well. Now, if we look at the history of DDIs in Florida, so right now, one DDI open to traffic. That's the one in Sarasota. We have 7 DDIs that are currently under construction. We have 8 DDIs that are in design and 21 that are in early planning. What I think you should note, though, is look how quickly they're becoming embraced. It's just that one. But now we've got, all right, so now 7 are in construction. But now by the time you get down to these early planning, we're at 21 of them. So it's taken off. And so that's, again, part of the impetus for why this webinar series is in place. We want DDIs to be an alternative that you guys are evaluating, but we want to make sure that we're putting them in the right locations and in the right context. So the DDI is a relatively new design concept, and there's been very little guidance or criteria to assist designers with the decisions that have to be made. For those early DDI projects, the one that was constructed, the ones that are in construction, the department relied on 3 primary information sources for design guidance. The first source was the national guidance, the FHWA DDI Information Guide, which, the most recent version is 2014. They have another version which we'll get into that's coming out. The second source is from other states, so lessons learned, best practices from other states. Missouri and Utah were some of the first states that implemented DDIs, and so they were the ones that also were the first states to develop DDI design guidance. And then the third source is, engineers with the national experience in DDI design. 10 years ago, the number of DDI projects a single engineering firm would have worked on maybe you count on one hand. Whereas now, like I said, I've been fortunate enough to work on a couple dozen DDI projects. So there is definitely, a lot more opportunities for people to be bringing those best practices, those lessons learned. So Florida DOT went 9 years through 2020 without any Florida-specific DDI design guidance. And in November of 2020, FDOT published the Development Design Criteria, D217, Diverging Diamond Interchanges. So this was the first document that provided Florida-specific DDI guidance and criteria. And the DDI, or the DDC D217, is located on the Florida DOT Design Manual webpage and covers the major DDI design topics. Some of those we're going to cover here. So hopefully you guys have seen that and been able to, at least look at it. And so D217 has three main purposes. First, provides guidance that is specific to the conditions and the needs of Florida. Prior to its publication, the only guidance that was available was the national guidance and guidance from other states. But as we know, conditions in Utah or in Michigan are going to be different than what you see in Florida. Different driving population, different weather considerations, everything. So, second, it serves to provide consistency to design parameters and details for all DDI projects throughout the state and across all the districts. This will improve the driver expectation since all projects using the developmental criteria will have a similar look and feel. And third, it provides a framework for continuous feedback and improvement of the design criteria. The developmental criteria is intended to be fluid, allowing for continuous revision and improvement based on feedback from engineers and designers working on the actual projects. And I think that's a critical piece. This is a start, and as best practices typically evolve, they continue to evolve, meaning that as things come up, as better practices exist, this criteria will also evolve with it. The major topics that are covered in D217 include the traffic operations, the geometric design, multimodal accommodations, signing and pavement markings, and signalization. And since developmental design criteria is new and not that well established, a formal design variation process can be streamlined. Written design variations are not required to deviate from developmental design criteria. Instead, a request to deviate from the criteria can be made directly to the DDC monitor, which is listed on the website, and the specific issues requiring deviation discussed. The DDC monitor will then either accept or reject the request based on the discussion. Uh-oh, somebody just said something about no sound. Can you guys hear me?
I can still hear.
Okay, good. I just want to make sure. Made me nervous. Okay. And then the final point on this slide is that in the case of conflicting criteria or guidance, the Florida-specific developmental design criteria will take precedence. So that's an important thing, because just because you potentially see something, say, in the FHWA national guidance, doesn't necessarily mean that that's what governs it if Florida has something different. David, do we want to touch on any of these questions or comments?
There's one about operations. It says, consider discussing the interchange clear movements. Is that something that we want to touch on later when we get into the operations section?
Yeah, I think that would be good, yes. So hold tight on that one, please.
Okay.
Yep.
I think that's the only other one we have.
Perfect. Okay, great. Now let's keep going then. Oh, get my slide going here. All right, perfect. So let's talk a little bit about the DDI reviews that we've implemented. So the FDOT policy on DDI review is found in the FDM, Chapter 116. It states that DDI projects on a state highway system require central office review for all design phases, and that a representative of the state roadway design office must be included as a lead reviewer in the electronic review comment system. The initial DDI review package should be submitted with the Phase 1 plans, and the submittal requirements are given in the FDM Article 301-4 and include traffic analysis results, geometric layout in both CAD and PDF, auto turn analysis, and the master signing plan if available. The traffic analysis results allows the reviewers to verify the proposed lane configuration and the storage lengths of the DDI, make sure that they're consistent with the traffic analysis, and that the proposed facility will operate at an acceptable level of service. The geometric layout will include all major features of the design, including the existing topo features, the horizontal and vertical alignments, the lane lines, the shoulders, curb and gutter, barrier wall, retaining walls, the bridges, the bike and ped facilities, stop bar locations. When we see this, we really like, the reviewers like to see the CAD and the PDF formats, because the CAD files allow the reviewers the ability to easily measure geometric features and to quickly zoom in and out on the areas of interest. So we can check lane widths, we can check lateral offsets, we can check sight lines. The other thing we always want to see is the auto turns, swept path diagrams for all the turning movements and the through movements, because with this unique configuration, there's certainly some vehicles that are turning, that they're moving. We want to make sure that the design vehicles are not encroaching in the adjacent lanes or shoulders. And we really like to see a master signing plan because we want to be able to verify that all guide signs are properly located and consistent with the lane configuration, and that the message is correct on those guide signs. And so the review process for DDI submittals is basically the same as for any other project. You know, the reviews are administered through the ERC system with a representative of the RDO listed as the lead reviewer. Once notified, the review will be conducted by the central office with the assistance of an experienced review consultant. When the review is complete, the comments will be entered in the ERC and a project team meeting scheduled. The purpose of this meeting is to go over the comments with the design team, resolve any outstanding issues, and discuss the deviations from the DDC, the developmental design criteria. The meeting can also be used to discuss the potential revisions to the developmental design criteria. So I think that's a huge benefit because it certainly allows us, you know, it allows David, who helped draft the criteria, to listen to other perspectives, or maybe what we put in there doesn't really work, and maybe it's a good solution but not really practical. And then after the meeting has taken place, the comment responses will be submitted to the PM and closed out by the reviewer. So there's a pretty structured review process, but hopefully we're seeing benefit by the districts that have already engaged this review process. And this, what you see on the screen is just an example of a DDI that was reviewed and the comments that were dropped in there. All right. So that covers the, what I would call the initial DDI overview of what we're thinking. Hold on one second, I just want to make sure real quick. Oh, okay. I'm seeing some things about no sound, so I'm just nervous that, but it sounds like people are okay now. So, all right. So now we're going to transition this webinar into focusing a little bit on those key DDI development features. And so that's going to be, you know, what we see here, those traffic operations, geometric design, traffic signals, signing and pavement markings, multimodal accommodations, constructability, plan detailing, and public involvement. So we're going to touch on these today, but all the ones that you see that just highlighted in red, those dates that are after those are when we're going to touch on, we're going to take a little bit deeper dive into each one of those. Each one of these topics that are in red are those 1 hour specific discussions on, just say, traffic operations on August 10th, geometric design in 2 weeks. Signing and pavement markings is in the middle of July. Multimodal accommodations, remember that's the new one that took the place of plan detailing. That's on August 24th. And then plan detailing and public involvement we've combined into a single 1 hour session on September 7th. So for those 6 areas, we'll touch on them in this webinar, but we're not going to dig too deep because we're going to want to hit those again on those dates. All right, so let's touch on some traffic operations first, because this already seemed to be a few of the questions that were coming up as part of this webinar. And so, you know, there's a whole lot of verbiage on this slide, but basically what it's saying is DDIs have been shown to work better than a traditional diamond because of the simple two-phase signal operation and because the left turn vehicles are free flow after they go through one signal. And you can compare it to certainly to other interchange configurations, but you're typically seeing these same principles, which is the simple two-phase signal operation and the free flow left turns make them a good choice. Now, as again we stress, needs to be evaluated through a corridor and not just the interchange. So I want to touch a little bit on a flow chart here because I'm an engineer and I love flow charts. So
Hey, Brian.
yes.
Sorry to interrupt. There's a couple of things that I want to answer. There's a couple of questions on the review process.
Yep.
Before
Absolutely.
you get too far into it. One question is, if the DDI is reviewed during the IAR process, is it reviewed again during design? And the answer to that is yes. Central office is involved with the review all the way through the 100% plan. And the other question is, have you reviewed the Transoft Nexus DDI? It's a full analytic geometric compliance and auto turn built in. I can answer for myself. I have not. I don't know if you've had any experience with that or not, Brian.
We have. We actually were. We helped Transoft optimize it, if you will. They kind of gave us a standard package and we played with it. It is a good package. I will also stress that it's not out of the box for every application for every site. It usually is a really good starting point, but then you have to really tweak it using your geometric design principles that you will learn or you already know. But it's a very good, I'll tell you, it's a really good way to get a quick start to a DDI layout. So when you're at like preliminary engineering, you're in that early planning stage, you can drop one of those in and literally just a few minutes and get a pretty good handle of where the general footprint's going to be, that sort of thing. When you start to drill into the design, that's where you want to, kind of take that as your starting point and then massage it as you need to. But it does, Transoft also is the one that developed AutoTune, so they've got all that incorporated in there. So it is a good tool.
Is Brian Martin on the line? We have a question about adding the coming webinars to the calendar, to the Outlook calendar.
Yeah, when you register for the webinar, it will email you a confirmation. From there, inside that email, there is an add to calendar function in the text of the email. That's how I always do it. And just as a point as well, and Brian touched on it in the very beginning, we did update the titles of those sessions, but if you already have registered for those sessions, the link is exactly the same. You don't need to re-register or get another link.
Yep, great.
Okay.
All right, so let's go back to our flow chart here. So what I want to show is the correlation between understanding the operational analysis and doing geometric design, because they certainly go hand in hand on anything we do, not just the DDI. But the first step is we need to establish those design hour volumes. We need to know what the traffic is in the design year for what we need to develop. Once we know the traffic, then we can pull the geometrics in to sketch an initial lane configuration. And this, again, we talked about what Transoft's tool does. This is where this comes in really handy. At this stage, you're sketching something in just to get a general idea of the footprint that you could potentially have. And then once you've done that, you ask the question, does the lane configuration meet the desired project operational goals? And if the answer is no, let's revise the lane configuration. So a lot of times what could happen is, we may, the initial volumes may say we need 2 lanes in each direction at the crossover intersection. But the problem we may run into is that queuing, because only 2 lanes are at the crossover intersection, may extend too far back and then go into the other crossover intersection. So for that, we may need to add a 3rd lane. so that we can shorten the queue and reduce the green time for that direction. And that's just one example. So if that's the case, we revise the lane configuration, come back, we ask the question again. Does it meet the desired project operation goals? Do we get acceptable level of service? Assuming the answer is yes, now we can drill a little bit deeper into geometrics to sketch the initial alignment for the crossroad, including the crossover intersection angle, the ramp terminal curvature, etc. So where is the crossover is going to be placed exactly? What is that angle? How the ramps come in? What's that distance there for the clearance interval? That sort of thing, which we'll get into. Then let's develop the initial signal timing, because at that point now we want to kind of tweak this a little bit. We want to make sure that the signal timing that we're proposing for the two crossovers, definitely work for the interchange. And then let's make sure we're assessing the corridor operations. So don't just look at the DDI in a vacuum, but let's look outside of it. Are we impacting in a negative manner the intersections that are close to the DDI? Does something have to be done to those intersections? Because in theory, we've popped the plug, right, at the DDI. We've now created a more efficient interchange that's getting traffic through it better. And then let's identify available right-of-way and constructability constraints, including utility conflicts. So what's out there that potentially we need to be missing? And as you can then see, we iterate to optimize the design. Now, this is certainly an oversimplified process, but it shows you kind of what you have to do, and oftentimes it takes iterations. You'll see as you get into a DDI design how quickly there are all these different aspects are related, and how quickly if you change one thing, it has a ripple effect throughout the DDI. Change that crossover angle, and it changes the curvature, it changes the lane width needed, it changes so many different things that you then have to make sure you're chasing all that through. So that's that iteration to optimize that design. All right. So we talk about traffic operations. The common myth I always hear, and I'm going to say this is a myth, is that to break a DDI, you put a signalized intersection really close to the DDI. And I think what I have shown you earlier is the way you break a DDI is because we split phase of through movement at the crossovers. If both of those cross or through movements at the crossovers are very heavy, that's how you break a DDI. The closely spaced intersections is something that is challenging, but we can work through that. So I'll give you an example here. So this is a real situation, real project. 560 feet on the left side, 530 feet on the right side. Both of these intersections adjacent to this DDI are signalized. Now, first thing I'm going to tell you is there is no magic bullet. It's got to be greater than 400 feet. It can't be less than 200 feet, whatever that is. There is no magic formula. But see something here. So I'm going to use an example on this right side. And so this right side is the one, if you remember, it was 530 feet away. So we're going to focus on this intersection right here that's highlighted in red. So again, close to the DDI. We've improved the interchange. The DDI now works very well, and it's dumping traffic into this adjacent intersection with a lot more frequency than it was. So this intersection here was the existing lane configuration. It was a single through lane, or I'm sorry, a single left turn lane. Again, you're on the side street looking at the arterial, and it was a through right movement shared. So at the single left turn, it required a certain amount of green time to clear that left turn. So what we did is we adjusted the intersection to give more green time back to the primary road. So to give more green time back to the heavier arterial, we added a dual left. By adding a dual left, we then did not need as much green time for the secondary street, which gave it back to the arterial. It's part of that signal timing analysis we looked at, and that's where we talk about looking at the whole corridor. Now, one thing that we didn't think about, and I'll go back to this for a second, you'll notice that it's a dual left where there was originally a single left. So the dual left, when they would now make this turn onto the arterial, drivers had an option or a decision they had to make. And oftentimes what we were seeing as soon as this was implemented was this issue here, where say drivers that were used to the intersection when it was a single left, they would get over into the left-hand turn lane and they would make their left turn, and then they'd realize, whoops, I need to be in the right-hand lane because I need to go north on the freeway. At the same time, I had drivers that were in the shared left through that were turning left and realizing that they needed to cross the freeway and go south on the freeway. So they were making a lot of lane changes here. And in this particular segment where you see the blow up or whatever, that was a problem. Now, I always make the caveat, don't blindly trust your traffic simulation models. We ran this in Visum before we put this thing in the ground. Visum assumed everybody was in the lane they wanted to be in already. So there was none of this turbulence that was shown in the model in this link. We got it out there in real life, and lo and behold, we saw a spike in crashes right here. Now, they were not severe crashes, but it was enough of an annoyance on a brand new DDI, the first one in this particular state, that it was going to give it a black eye. So sometimes you need to make adjustments after construction is completed. So in this particular case, we added that sign on the right. And that sign was not part of the original construction plans. And what this sign tells you now is it's a dual left, but if you want to go north on I-270, you need to be in the right-hand lane. Make that left turn, you're already now in the right-hand side. Simple fix, but not something that my traffic models showed. So we definitely want to make sure you're not blindly trusting the traffic models. Pavement markings, pavement tattoos work very well as well. They can help eliminate that or alleviate that confusion when you're making a turn from the secondary street near a DDI. So this is just one strategy for how to essentially steal green time back and give it back to the arterial where you've just put the DDI to these adjacent intersections. Again, in our attempts to try to improve those intersections so that we're not just dumping the traffic into these intersections and causing gridlock at these adjacent intersections. And then, one of the questions I always ask is, can we eliminate a signal that's adjacent to the DDI? So in this particular case here, we put a median in place and we made it a right in, right out. And by doing that, there used to be a signal there, but by making that a right in, right out, that cleans the flow up. On the other side of this interchange, we had a lot more challenge because this was an offset intersection. It was pretty nasty. It was contributing a lot to the problems with the interchange itself. So in this particular case, a roundabout was added. So, again, from a flow standpoint, the arterial runs pretty well through here. It gets out of the DDI, goes into the roundabout, and functions very well. But again, one of the things that I can't stress enough, and the question was asked earlier, make sure that you're looking at the Ddi operations as a corridor and not just the isolated interchange. So think also about the lane utilization through a DDI. Think about how the lane assignments affect the traffic flow with our goal of trying to not just minimize or maximize the efficiency, but minimize the turbulence within the DDI. So here's an example. That red highlight you see at the top of the screen is a drop lane. So it's a 2 lanes through the DDI, but then once you get past the DDI, it's a right turn drop with only a single lane that goes through. So that's kind of what this highlights down here at the bottom. It's 2 lanes across the bridge. So what happens is, that left-hand lane is a lot of the traffic that wants to go to the freeway. So they're coming across the bridge, they're slowing down to make that left turn because that radius is, a little tighter than, than the through movement would be. So that creates a little turbulence right there across the bridge. But then as you get through the crossover, you create more turbulence because now drivers that potentially were trying to, get through the crossover intersection, so they're sneaking over into that right-hand lane, but they want to go through the corridor. They then have to make their way over to the left, which creates more lane shifts and turbulence. And then certainly right here, because traffic could potentially have been trapped in that right-hand turn lane. These are things, again, that we just need to be aware of as we're assessing the DDI as a corridor, that this doesn't always show up in the VISA models. So when we have drop lanes outside the interchange, that creates turbulence. So in a case like this, if there is any way to, instead of making that a drop right turn lane, can you make it a through right? And then a couple hundred feet past the intersection, merge that through lane in. It's not ideal, but because you don't want to chase this project, for hundreds of miles, it at least gives that opportunity to get past the intersection before you merge it in. And so we're going to dive a lot deeper into the traffic operations on August 10th from 2 to 3 p.m. So hopefully.
Hey, Brian,
Yes, sir.
before we move on to the next topic,
Yeah.
did we touch upon the question that was asked about interchange clear movements? Says the SPDI clears the entire interchange ramp terminal per phase. I think the DDI could have a split phase, and therefore the through movements could get stopped twice, once at the approach and then again before crossing back over. This results in significant delay. Like like you said, high uneven volumes, the DDI has advantages, especially from the ramps. DDI is open to traffic in Miami, constructed by MEX, and what about this one?
Yep. So, sorry, give me a second. I'm going to look through this one real quick. So speaking of operations, please consider discussing interchange clear movements. The single point clears the entire interchange ramp terminal per phase. I think DDI could have a split phase, and therefore the through movements could get stopped twice. That's absolutely correct. Depending on how much volume you have through there. But again, that's where you can play around with the signal timings. Because if it's a really heavy through movement, you can set the timing potentially to allow for the traffic to get through that first crossover and then make it through and hit a green light the second one. Part of what you get into then is if you've got too much queuing, that's where you may be expanding the DDI. Instead of 2 lanes, it's 3 lanes. Or in the case of Sarasota, it's 5 lanes. And so that's part of that balance that you're going to have to evaluate when you're looking for traffic operations. So it's a great point. And I don't want this webinar to make it sound like it's DDI or bust. Certainly other options are available. A single point is one, a diamond is one. All I'm doing is just walking through what we see characteristically on the operations of a DDI. So you said that there's a DDI open to traffic in Miami?
Yeah, I guess I missed one when we said there's more than one on the state highway system. That's
right. They're opening up because I think even the Express Authority is starting to look at them too, aren't they?
Yes.
Yep. So that's good. Let's see real quick here. Some locations have heavy cross-street traffic as well as heavy left turns from the ramps. This may make simple 2-phase operation not practical. What is your recommendations for such conditions? Yeah, I mean, that's a good question. I think we're going to touch on some of that on August 10th. So hopefully you can stick around. I actually don't do a lot of the traffic analysis. I do a lot more of the geometrics. So, but the person that we'll have on for the traffic analysis, he will be able to, also help spitball what some of those options might look like. What's the next one, Dave?
Well, there's one, will it work with the power when the power's out? The answer to that, it should be no. It's just like any other signalizing intersection.
Yep. Yeah, I mean, that's exactly right. It's just like any other signalized intersection. So whatever strategies that you could, backups and that sort of thing on your traffic lights for a signalized intersection, you could do it on DDI.
This was this one on access management. The access management standard in the FAC rule 1497 has magic number on the proximity of adjacent intersections. The standard is very difficult to achieve in many cases.
Yeah, that's correct. That has a lot to do, I think, with that limited access, 600 feet, 1,000 feet, whatever that dimension is. And you're right, that becomes, what we're talking about when we talk about that magic number. It has to do with, again, that traffic operation. So if we're solely looking at, the adjacent intersection and will it break down, or is there enough space for queuing and that sort of thing between the intersections? That's what I'm talking about when I say there's no magic number, because there are modifications that can be made to the intersections to improve those. I see the last question. What are some areas where national guidance diverges from DDC 217? Truthfully, I don't know if there is any right now, David.
Well, one thing that we really stress is that we want to have nice, smooth alignments through there and have like tangent links between adjacent back-to-back curves. That's not really touched on a whole lot in the national guidance. That's the only thing I can think of right offhand.
Yep. And that actually is being evaluated. So I think it will be soon added to the national guidance, if I was a betting man, David. Because you're right. One of the things that you're seeing and what you're referring to, which we'll get into in the next section, which is geometric design, is we have the reverse curvature, what creates that bulb approach coming into the crossovers. If you don't have the tangent link between the reverse curves, trucks tend to shift the load, especially if it's a tanker truck, if it's something like that. And as they're going from one curve immediately into the next curve, as they're coming into that, that can cause a safety issue. So putting that little bit of a tangent, it one helps kind of center the load, but also helps center the vehicle within their lane, which really will help kind of keep your lane width requirement a little less. So,
right.
Yep, that's a good point. All right. So let's go one more section here, and then we'll take a short break. So let's touch on geometric design. And again, like I said, we're going to cover this later as well. So I don't want to hit this very heavy. And so, the biggest thing that I always want to stress with geometric design is we need to make it intuitive to drivers. It's not always, when you're looking at a top-down view of a DDI, it can be very confusing. But when you're looking at the windshield view, like what you see on the screen, we want to make it so that it would almost be difficult to make the wrong choice. And that's really what I mean by intuitive to drivers. And one of the things that we like to do is very similar to what you would do for a roundabout is, reduce those approach speeds as we're, coming into both the crossovers and then across the bridge. The reason for that, again, is this is that location where we talked about those crossing conflict points. There's one right here and there's one on the other crossover intersection. So we can reduce those speeds and we can do it gradually without shocking the driver. Then that's a good thing. Again, let's just keep promote those lower speeds through the crossover. One of the things we also would like to do is not to introduce curvature within the crossover. Now, this image here is from D217. It's also from FHWA's guidance. And it kind of shows that 100-foot minimum tangent length through the crossover, 10-foot minimum on the one side, the departure side, 15-minute on the approach side. And that's good. That's what we want to see. Really what I say is we want to make sure the tangent lengths extend past the intersection. If you're only getting 13.5 feet, David, correct me if I'm wrong, I feel like that would be fine as long as we can extend it past the intersection.
Yeah, that's correct.
Yep. The other thing I would stress is there are times where your crossover intersection may actually be on a horizontal curve for one of the movements. And I can think of one in Michigan where that was done. And if that's the case, don't force a tangent in there if it's already on a single curve that goes through the crossover and doesn't change direction. Keep that. That's why I say don't introduce curvature within the crossover. So So that's just kind of, again, we talk about that intuitive to the driver. We don't want the driver to have to change the steering wheel or the position as they're going through what is the most critical location, in my opinion, from a DDI's perspective, because of the crossing conflict point here. And the other thing to really focus on is the difference between what we call the crossover angle versus the eyebrow. So in 2014, FHWA put this statement in their guidance that state DOTs recommend crossover angles of no less than 45 degrees between opposing approaches. And I will tell you that I agree wholeheartedly with most of what FHWA says, but I do not agree with this statement. Now I can kind of show you a little bit why. So this was actually the first DDI that I designed, and we read that statement in the FHWA guidance, and we said we are going to meet it. So we put a 45-degree crossover angle here at this particular intersection. What we later learned was this point right there is the most critical point, because that is what we call the eyebrow. And what this is that it's a physical impediment that keeps drivers from doing that maneuver right there. Because obviously if they're doing that maneuver, then they're going into the wrong direction, right? As they're approaching from the other direction of the crossover. But what we would want to do is so for example, if it's that truck that's making that move where that arrow is originating from, if he is not paying attention, there's no other cars on the road, he's looking at his cell phone and he's going straight through here, we want to make sure that he hits something, a curb or something that's not going to cause significant damage to him, but it's going to hopefully wake him up, jar him, and keep him from continuing straight. That's really the goal and what this eyebrow is. But the difference by focusing on the eyebrow as opposed to the crossover angle is if you were focusing only on the crossover angle, then it doesn't really matter how wide the intersection was. Whereas when you focus on the eyebrow, that eyebrow or that crossover angle gets flatter with less lanes. You can see here, it's 2 lanes in each direction. There's my eyebrow. There's what, that keeps these lanes from getting, from creating that ability to cut through there. This intersection is 34.5 degrees. Now that's really flat. Here is the eyebrow at this particular location. Again, that curb height that keeps the driver from continuing through and hitting it. And that's at 39 degrees. So I would honestly say that you don't need to focus as much on the angle as you do on that well-pronounced eyebrow. Because the flatter you're able to make the crossover intersection, the less right-of-way impacts, the less bulbous nature that you have approaching the DDI, that sort of thing. However, recognize when we talk about traffic operations, the flatter the intersection, the longer the intersection. In other words, the longer the distance it takes to clear the intersection, which can hurt your clearance interval. So there's a balancing act here. And so when we look at the crossover angle versus the eyebrow, that's what we're talking about. We're talking about balancing that crossover angle, or that the definition of the eyebrow, with the right-of-way impacts, such as right here. If we had this thing even greater of an angle, we could be bulbing up into that property up there. The additional cost in this particular case, if I could have flattened this angle, then I could have potentially gotten out of that retaining wall that was in this bottom right corner. The ramp curvature here, if I can go with a little bit of flatter of an angle, then I could potentially have improved or increased the radius of this, entrance ramp. And the ramp decel length here, again, depending on what I can do with the crossover angle, can impact where the diverge or that gore is for that ramp. So there's a lot of things that are interrelated, certainly, when we talk about the crossover angle. But again, don't necessarily focus it as an angle that you're trying to achieve. Focus it on, I need to achieve a well-pronounced eyebrow. So when we're looking to develop a DDI, especially if you're modifying an existing ramp, an existing diamond, the first step is let's locate the intersections. And when we do that, I feel like they should closely match the location of the existing ramps intersection. And if not, what ends up happening is you end up getting very large, uh, dead space in the intersection, very large intersections, or excessive right-of-way impacts. So, if you have to move them maybe towards the bridge, but not away from the bridge, because away from the bridge becomes those large intersections with a lot of right-of-way impacts. Your next step then is assess the existing bridge. What is the footprint that you can put underneath, if it goes underneath or above, across the bridge? So in this particular case, I was kind of locked in. I had 2 lanes in each direction was all that I could put in here. So my DDI needs to be positioned, my crossover intersections need to be positioned such that I can put 2 lanes under the bridge, and then if I have to open up a decel lane for my left turn slip, that I have enough room from that bridge to the crossover intersection. And then, identify how the geometrics impact the traffic operations. So here's an example. So these 2 dimensions here, are essentially my clearance interval, okay, my lost time at the intersection. So for that, I would like my northbound exit ramp, which is coming from the bottom of your screen. I would like to reduce the amount of distance from the crossover intersection to where these ramps tie in. Because, it's that situation where if my westbound through movement through this crossover is, as soon as he goes red, or right before it goes red, the last car goes through, has to travel the distance along that red arrow before the light can turn green for the left turn from the ramp. That's that lost time or that clearance interval. So we want to minimize that distance if we can. And then what you see in the red here, we actually like to maximize as much as possible. So the red shaded boxes that you see there are the distance that the queuing can extend back without locking out the free flow left or the free flow right. So as you could see, in if you're heading eastbound, so the box with the Roberts Road in the middle of it, the left-hand through lane can extend almost all the way back to the bridge and not lock out the free flow left turn to the freeway. If that distance is really short, then it won't take much to lock that out, and then that free flow left is no longer free flow. So those are the things to think about when we're looking at the geometrics. And that's just a little bit of it. We're going to cover more of that in 2 weeks.
Yeah, couple questions. For some conditions, there may be large speed differentials on the arterial versus traffic going through the DDI. Is this a safety concern? What speed differential is acceptable?
Yeah, so I think if I'm reading this question right, I think what we're saying is, so let's say it's a high-speed arterial where, say, it's 55 mile an hour posted speed, but as you're approaching the DDI, you don't want them going 55 miles an hour through the DDI. And I think that's where I kind of showed that one image that showed the speed stepping down as you approach it using that curvature, physical geometry. Again, what speed differential is acceptable? I kind of liken this to a roundabout. You can put a roundabout on a high-speed facility. You're just going to introduce a little bit more curvature to kind of get the drivers to slow down. I think you do the same thing with the DDI. I don't think I've seen a number necessarily a hard and fast that says that. Dave, do you have another one?
Yeah. Approaching the crossover, have there been issues at night with oncoming headlights blinding the traffic from other directions? What was done to address this?
Yeah, that's a great question. There's some research that's being done right now actually on this very topic. The easy answer that I would say is it's not usually a huge issue because you do add that curvature to bring the drivers towards the crossover, right? And so what ends up happening is you don't get the headlights directly in your face, but you might, you'll see them a little bit, right? But there are opportunities to potentially use some glare screens or something like that if you believe it's a problem. So far, I don't think too many states have really seen an issue with it or complained about it. I know I'm pretty sure Utah and Michigan and Missouri that all have design guidance. I don't think they've really made too much of an issue with it, but have offered up that you can certainly look at barrier that's kind of set back a little bit from the curb, but with glare screens or something like that. But you do have to be careful. Are you trading potentially one safety mitigation for a safety concern? In other words, you may be cutting down on the headlight glare, but you're adding a um, crash issue with the barrier or something to that effect. So, but like I said, I don't think we've seen too much real issues with that. But it's a great question because it's something that a lot of people ask.
Okay. Does the tangent length include any super elevation? I'm assuming that's the tangent length through the crossover. So could you touch on a little bit of how we develop the crossover intersections with the super elevation transitions?
Yeah, we can, and that'll definitely be covered. Paul, in the June 29th session, because this is a question we get a lot. There's a couple different ways to handle the super elevation through the crossover intersection themselves. You can either kind of tabletop the whole intersection, having it slope to one quadrant or another. You can crown it down the middle to where the drivers have to traverse a crown line as they go through it. So there's a couple different options. I guess the one thing we always try to stress is we're not trying to build a racetrack, and I say that somewhat facetiously. So we want to make sure that we're not adding a bunch of super elevation through the crossover intersection itself, because we're not trying to promote higher speeds. We typically don't see anything much more than just normal crown or reverse crown. It may be, or remove crown. It may be 016 in one direction or 016 in the other direction, depending on how we warp the crossover intersection. And we can use the tangent lengths to rotate the super in that section. But again, that tangent length's also there to kind of center the vehicle and to center the load, if that makes sense. So, David, do you have anything else to add to that one?
Well, yeah. The other thing you want to think about is the grade of that of the arterial going through there. You're going to have to, one side is going to have to come up to match the grade of the other roadway as you're going through. So that's another wrinkle in trying to develop the intersection details through the intersection.
Yeah, I mean, it also comes down to drainage. Oftentimes these crossover intersections become very large. I mean, that Sarasota DDI with the 6 lanes in each direction, I mean, it's massive. That intersection is huge. And so how do you drain that intersection? So there's a lot of things that come into it. So like I said, stick around in 2 weeks and we'll touch on that a lot more. It's a great question.
There's another question about locating pedestrian accommodations and pedestrian facilities. Can we can save that to get to that section?
Yep, yeah, that'll come up here in about probably an hour. So, okay. Yep, absolutely. All right. So Paul says, so is more of a plateaued intersection. I'm not sure what the question necessarily is, but yeah, sometimes, so we will see, when I say a plateaued intersection, a lot of times, or a tabletop intersection, maybe it's the same thing as what you're saying, is you may see it all, the intersection is all sloped in one direction. And then the cross slope is warped or adjusted to meet the intersection. And that's done if it's a large intersection, but you have a specific location you want to drain it, a lot of times. Or you could see it, again, like I said, crowned about the middle. So. All right. I think with that, let's go ahead and take a break. It is 3:35 now. If I can say everybody is back by 3:45, that'd be good, David?
Yeah, that sounds good.
All right. So thanks, guys. And if you have any questions, feel free to put them in while we're on break, and then and we can address them afterwards. We'll see you guys in 10 minutes. All right. Can you see my screen again still?
Yep.
Perfect. All right. So let's go ahead and get started. Hopefully everybody's back. So now let's touch on the traffic signals for the DDI. So, things to think about. Let's first determine where to place the signal heads along the arterial. So the signals on the back side of the crossover is a pretty common place. We need to make sure that we ensure proper distance from the stop bar to the signal head. Also, the single mast arm for both directions can be used. But if you do that, watch the alignment for vehicles approaching the signal heads. Make sure that they're seeing what I'd say the right signal head in case there's any that are conflicting as you approach the far crossover, potentially if you've got a left turn or if you're approaching the, if it's a left turn signalized crossing for, say, a pedestrian crossing. So just make sure that the drivers that are approaching the crossover are seeing the correct signals if you put them all in the same mast arm. And so one of the things that we run into, one of the challenges we run into is those supplemental heads that are used to help, people see the signals because of the curvature that we're introducing, certainly on the ramps specifically, those exit ramps as they're approaching the interchange. So, we use this one over here on the right side as an example. And so, seeing the signal head along the ramp when approaching, that's what those three signal heads are right there. We also have a supplemental head there to the right, which again just kind of helps re-emphasize what, as you're coming around that curve, make sure you're seeing the signal, when it's appropriate to go. But there's also this supplemental signal head that points down the ramp, which is, very good to, to orient the driver so that they don't, there's no mistake when a vehicle, because especially on a dual left turn lane, there are vehicles that can be in their way as they're seeing if they can't see all 5 signal heads, but they can see one of them. That's what we're trying to get. And we want to avoid the confusion. I think that's kind of the biggest challenge that we run into. So we're going to use this one over here on the left as an example. So again, I'm approaching, this is a driver's eye view. I'm approaching the intersection from the ramp. So there's my 2 signal heads at the stop bar. Here's my 1 supplemental signal head also pointed to the approach on the ramp. And that circle there, I don't know how well you can see it, is the supplemental signal head. Now, here's the problem. That signal, right as it's shown, is a question, what's it pointing towards? So if the image on the left is the top-down view of that, so from the driver's eye, I'm looking at that signal. But I don't know which one that points to because this is a 2-phase signal, right? But each of those 2 directions are different. When the right-hand side signals are red, the left-hand sides are green, and vice versa. So when you put a supplemental signal head right in the middle like that, which is oftentimes a good place to put one from a space real estate, you need to make sure it's clear which direction the signal head is for. And so the way to do that, one way to do that is use arrows. And so what you can kind of see hopefully on your image in that green circle is a up diagonal arrow that tells the drivers they're approaching that intersection that signal is green. So as they come around that curve, that white truck that you see there, he's coming around and he's going to stare at a green light. And so I don't know how well you can see that, but if you were to see inside that red circle, that is a green ball. And so the problem you're running into is as I'm approaching that in this vehicle that I'm in, Maybe I assume that that is for the through movement that's curving to the right, but maybe it could be the left turn signal. And so there's confusion there. And so here's a great example. This was actually out at my site visit. And you can see that this is a ball. It's a red ball, which actually is the supplemental signal head for the through movement on there. As you can see, the red on the right side, the red balls that are staring at you on the right side. The interesting thing is obviously the left ramp, the turn to the left is a free flow maneuver. A car came up to this intersection, it was unsure of what that signal head was showing as far as what direction, and came to a stop, even though they were turning left. The car behind them didn't expect that driver to stop and almost hit them. And of course, I couldn't get my camera out fast enough to take the picture of how close they got. But again, that's just that confusion. So whatever we can do to, minimize that, again, using arrows is very helpful. When we look at the crossover intersections themselves, the green ball is a very good strategy just because that's the signal you're looking at, that's the direction you're going. You could also look at using straight up arrows. So like what you see here, again, signifying that's the through movement. And even a diagonal arrow up would work well to just kind of reinforce to the driver that I need to be moving over to the left. Don't go straight and potentially go in the opposite direction. Interesting about this DDI is there is no tangent through the crossover. So they've got some other geometric challenges with this one, which I think is why they use those green arrows diagonal up to just kind of remind the driver, you got to get moving over to the left. So somebody, I believe, asked a question about earlier in this webinar about signalizing the right turns. And this is where we'll touch on that a little bit. And so, I think I told you my preference is to signalize the right turns anytime I'm doing a DDI. And largely for a couple of reasons. But the biggest one being, from a driver's perspective, when they approach an intersection, they tend to look over their left shoulder. And what they would tend to look at is, initially, if they're not familiar with this interchange configuration, they're looking to their, over their left shoulder, and that's the direction they're looking at. If they look in that direction, they potentially aren't going to see any vehicles because that is the opposite, that's the direction it's going away from. When they really should be looking there at that vehicle that's coming at them. So there's a potential that they could get a little bit confused and pull out right now, thinking that they are good and that vehicle that's now approaching them could potentially hit them. The other issue you run into is when you have dual turn lanes, then you run into vehicles causing sight obstructions. And so signalizing it just makes it cleaner. And this is actually out of the Missouri DOT DDI lessons learned from 2010. So even as far back as 11 years ago, they recognized this was a problem. The typical driver looks over their left shoulder and they see the expected oncoming traffic that's actually going away when actual oncoming traffic is what's coming at them. So this is a concern that why I like to signalize the right turns. And again, it also helps from a pedestrian crossing standpoint because it gives a pedestrian another protected crossing maneuver. And so when we do that, we like to also I like to implement no turn on red for the right turns. Again, it's your preference certainly, but if you allow them to turn right on red, then you're getting away from the benefit, in my opinion, of why you put the signal there to begin with. So signalizing it, no turn on red, because the skew angle is also going to be a problem. It's not always easy to be able to see. Drivers are having a tougher time potentially looking and locating which traffic they should be looking at. So for that reason, I do, like I said, like to, no turn on red. whether it be the one sign on the mast arm, potentially you put the signs right on the mast arm, right beside the signals, is a good strategy. And I would also argue to allow no turn on red for the left turns as well. For the same sightline issues, same sightline obstructions that you had with the right turns, the left turns are also problematic. So for the exit ramp that's turning left onto the arterial, it's essentially a one-way to a one-way, but I would like to see those no turn on red as well. And then we get into a little bit on the number of signal cabinets. This is a question that comes up a lot. Do we use one cabinet or do we use two to control the entire interchange? And really, there is no right or wrong answer. You can use either one. It's either one or two. If you use two, there's concern of connection loss to the controller. But the GPS clocks can alleviate some of these two cabinet concerns. So there are definitely some trade-offs with one versus the other. The Ddi Information Guide, the second edition, which will ultimately be the FHWA DDI guide, this is a table that's out of that, and it kind of just highlights very clearly the benefits and the challenges of one signal controller versus two. So the plus signs being the benefits, the challenges being the minus sign. So I don't necessarily want to read through all of this, but you can see it when this thing's being recorded, so you can go back and look at it if you wanted to. So it's just a situation of what is the best strategy for that particular location, for that maintenance operation, that sort of thing. So, all right, let's move over to the signing and pavement markings now. So the MUTCD does not explicitly address DDI signing details. There are a ton of options for how we sign, what signs we use, where we place them, how we do it. At the end of the day, what we're trying to do is minimize confusion. That is always what we're trying to do. Sometimes we get caught up in putting too many signs, and then there's so much visual noise that in itself causes drivers to kind of panic a little bit. So is there ways to clean up the signing so that it's not so cluttered? So Utah DOT, in their design guidance for DDIs, offered up some signing and pavement marking strategies for signing specifically. But a couple of things I wanted to point out on this, and this is why I say, excuse me, the practice is constantly evolving. So Utah DOT, they put this together. They said this is what we'd like to see for these overhead guide signs that you're going to see highlighted in yellow. So this is their standard drawing, if you will, that shows the overhead guide sign approaching the first crossover intersection along the arterial to gain access to the freeway. So let me step through this a little bit. So here's a real life example in Utah. And what I wanted to point out is this sign right here. It's a left-hand exit only, and it's a share through left. And my question is, are the left turn arrows confusing when they're so far in advance of the actual diverge location? So let's look at this in plan view for a second. So here is that sign. And that sign, remember that far left-hand portion of that sign said left turn only and a share through left, which is that movement right there. But here's my question. Could a driver believe that that is my left turn only? Or more importantly and scarier, could a driver believe that that is my left turn only? So it can be concerning if you're not thinking. Again, this is Utah put this out as their standard guidance and they're using it. But does this create confusion for a driver? And so here's an example of something we saw. They use that exit only left-hand lane. So, and that's true if you followed this lane all the way through the crossover intersection, you cut it through the interchange core, it drops to the ramp. So it is technically the right sign. It's accurate. But could drivers potentially see this and turn left at this first intersection thinking that this is my left turn on, that was to 95 south. So part of this is a geometric issue as well, that don't include the pavement. I don't know if you can see it. The pavement, it looks pretty squared up like it's a true intersection. So maybe get rid of and put a little bit of that curb cut to where it's not as easy for a driver to make that 90-degree turn. And so what may be better is to use straight arrows as you're approaching the crossover. Instead of, if you remember the sign that said next left or exit only, it's a straight up arrow. If you do that, then that could potentially alleviate some of that confusion. The driver's not looking necessarily to turn left right here. They're in the correct lane because that arrow tells them that, and they're following it. And then once they get it past the crossover intersection, then they can use that exit only or left turn or left diagonal arrow up. And so another question is, are the signs accurate? So here's one, for example. This is I-4 West. Tampa is the right-hand lane. But that sign is, oops, sorry, let me back up a little bit. So that sign is approaching the first crossover intersection. But the right-hand lane actually goes past the right exit, the right turn, and goes through the interchange. And so because of that diverge right there, putting his right lane is probably not completely accurate. Maybe that's where you would use the up arrow or the diagonal up arrow. Something to that effect. Or maybe you say it's next right. But again, just taking that step back, looking at the signing in general, are we communicating how to navigate this interchange to the driver? Especially, in Florida, there's a lot of tourists, a lot of people that maybe are down here who are not familiar with these interchanges because they come down for a week at a time, and then they go back to their homes, come down another year from now for a week at a time. So how do we communicate this to the tourists, if you will? And then a lot of times it just comes down to minimizing confusion. So you can see at this particular location, a whole lot of signs, a lot of visual noise, a lot of things that are distracting a driver. Similar signs at this location, but spaced better throughout the intersection, provides a little bit better visual of this particular intersection. Not so much noise from a driver's perspective, allows them to focus on what they need to be, which is that traffic signal and those cars. So now pavement markings is another good thing to make sure that we touch on. Certainly the start, whenever we're looking at turn lanes or we're looking at multiple turn lanes, we want to identify the appropriate design vehicle. And like I said, especially for those dual lane turning movements. One thing that we recommend is place any of your excess pavement between the lanes in the middle for use by trucks from both lanes. So that section right there that you see in the middle is pavement that can be used by the left-hand turn lane. That cab could actually go up into that lane, or the right-hand left turn lane where the trailer can drag across it. So here's an example. As you can see, that same intersection, there's the truck actually using that pavement too, which was good. I mean, we put it there, he used it. If there was a truck beside him, he would probably not have been in that pavement. But if there was a truck beside him and then this truck was actually like a passenger car, I could see that truck pushing up a little bit into that stripe lane. So you're just giving that opportunity without having to go crazy and widening that pavement, because without the channelization lines, the image on the left, that 2-lane ramp is about 44 feet wide. If they didn't have the channelization lines, you didn't have the striped veins, I could potentially see 3 or even 4 passenger cars at night pulling up to that because of the width. Problem is there's only 2 receiving lanes on the arterial. So that would be a real challenge and a real safety issue. And then here is another example right here of placing that pavement in the center to accommodate truck traffic. And excuse me, the D217 Diverging Diamond Interchange Developmental Design Criteria has a very nice figure on what we're expecting from for a design vehicle pavement striping. And this is where we talked about it during the reviews of getting the auto turn, because we always want to check to make sure, do you have enough width for these ramps? That's typically one of the most common comments I give is, I don't know if trucks can make it through your configuration. And depending on your ramp width could actually impact your right of way if it's on a right turn ramps. And this just shows an example of the striping in the middle and how the trucks could use it from either direction, basically, if you want to. And again, this is in the FDOT Developmental Design Criteria. And we're going to cover more signing and pavement markings in the middle of July. We're going to dive in a little bit deeper into what this means, what it looks like, some other best practices to minimize confusion through the interchange. All right, let's get into a topic that I think there's at least been a couple questions on already, and that is multimodal accommodations. So let's talk a little bit about the benefits of a DDI with respect to what I'll call multimodal. So it's going to be pedestrians, bicyclists, transit. So, and this is where, we can argue at times about whether it's truly reduced overall right-of-way footprint when it's compared to a conventional diamond interchange. But even if we're saying that it's wider, the pedestrian is oftentimes not forced to cross the entire width of the roadway in one shot. So if it's a conventional diamond, it's an 8-lane cross section for the roadway. A lot of times they're having to cross all 8 lanes to make it safely, in that one signal phase. Whereas in a DDI, they can do it in pieces, crossing just one direction. So it may not be necessarily a smaller overall right-of-way footprint, but it could be a smaller crossing. Two-phase signal control, reduces that pedestrian wait time, certainly, because it's just that much quicker that they're getting that green phase with the traffic. And then that's where I touched on the minimized crossing distances. And then that one directional vehicular traffic, again, similar kind of a roundabout where when you're crossing roundabouts, you're typically crossing those one direction at a time. You're getting to a little bit of an island, a splitter island or something, and you cross one direction at a time. It allows pedestrians and bicyclists as they're crossing to just look in one direction at a time. And then, opportunities for bicycle lanes and multi-use paths through the interchange. There's several. We'll get into what those might look like. All right, so challenges of the DDI for multimodal accommodation. We talked about the benefits. So, DDIs sometimes offer those altered travel paths by putting pedestrians or bicyclists down the center of the interchange between vehicular lanes. So this is an example of that. Traffic sometimes approaches from unexpected directions. Again, because you're crossing one direction at a time, it can get a little bit, confusing as to where they need to be looking. Unfamiliar signal phases definitely, because now it's a two-phase signal, but traffic is moving differently than maybe what you're used to at a traditional intersection. And then the uncontrolled crossing of turn lanes. So those free flow left turns that we talked about, oftentimes those free flow rights can be challenged because if it's an uncontrolled crossing, now they've got to look back and find those gaps where they can successfully cross it. And so, pedestrian accommodations are touched on pretty heavily in section 217.6 of the developmental design criteria. And it stresses that we need to be thinking about pedestrian accommodations early in the DDI design process. Because, you know, as we're designing an interchange, we often have to balance the needs and the safety, mobility of all users. So, and potentially putting pedestrians, you know, in this configuration makes the configuration larger or a different size. You have to accommodate if it's a pedestrian path down the middle, for example. You know, do we have spaces with the bridge piers? Do we have enough width on the overhead bridge? That sort of thing. All right, so let's take a look at the options that we have for pedestrian accommodations. So one is down the center of the interchange. And this is a common strategy that they cross to the outside as they approach the DDI. And then by the time they get into the core, they're actually into the center of the interchange and they're coming through the center. And then obviously there's the more conventional outside of the interchange. So there, in this particular example, you see in the bottom image, pedestrian paths go all the way across the outside, both directions, and then come all the way through and stay to the outside, obviously on each side of the interchange. So what we want to stress is center walkway for the center, or the pedestrian path in the middle, is the preferred option in Florida. The reason why it's preferred is because it avoids those free flow left turning movements, which are those. So the image in the top is that center walkway crossing, which shows, you know, how many of those pedestrian crossings that are stopped or decelerating versus how many are free flow or accelerating conflicts. You'll notice in that particular case, there's 2, and those are those free flow right turns. The image on the left is, or on the bottom, I should say, is the outside crossings, and you'll notice that they've added 2 additional free flow or accelerating conflicts. Those are the free flow lefts. Now this image also shows crossing the arterial in the middle of the interchange, which typically you wouldn't do. You wouldn't even need to set up. Typically what you see is that the pedestrian paths go all the way across the outside and continue on the outside and don't cross in the middle as well. So, you know, the reason why the center walkway is preferred not just avoids the free flow left turning movement, but it improves the line of sight between the pedestrians and the drivers when it's down the center. And I'll give you an example right here. So pedestrians getting ready to cross the road, the vehicles that they are most worried about, they can see pretty easily. There should be nothing obstructing them from seeing it, and vice versa. Vehicles can now look straight ahead and see that pedestrian. They come through here, and now they're crossing this, same thing. There's very little obstruction, if any, for vehicles to be able to see that pedestrian as they are desiring to cross that maneuver. Again, crossing one direction traffic at a time. And then it consistent with expectations, the pedestrian looking left first, because typically when you are crossing a roadway, you look to your left first before you step out, because that's the direction of traffic that is, you know, coming towards you, that's adjacent to your curb. So when you're standing here in the middle and you cross, you have that benefit of looking left first from a pedestrian standpoint. That is better. When you put the pedestrians on the outside, you need to make sure that you provide clear line of sight at all the crossings, especially these free flow lefts, free flow right crossings. Remember, the free flow lefts are the added crossings that the outside crossings have that the center walkway does not. And so, you know, you can kind of see this image right here. There's a crossing of a free flow left. And I'm standing, in this particular case, you're standing, you know, basically in the island, and I can see the vehicles coming at me. However, if I was standing where the red box is, I couldn't see the vehicles. Here's my view, and the vehicles can't see me. So that's a concern from a sight line standpoint, A pedestrian not being too sure about where to go could step out right now, and there could be a car coming around that corner pretty quick and clip that pedestrian. We want to make sure that we provide these clear line sights. And so if there's a bridge that's going over, for example, we want to make sure the vehicle can see both sides of the crossing, because a pedestrian could be on either side, right? It could be on the left side crossing to the right, or on the right side crossing to the left. We also want to make sure that they can see the signage so that they recognize that there is a potential of a pedestrian to be there. And we want to make sure that the pedestrian can see the car. And things like bridge parapets, bridge piers, we need to make sure that they're out of the way. So for that reason, we've got to be careful about where we place these crossings. So position these crossings close to the arterial does a couple things. One, it keeps that sight obstructions minimized. As that crossing, I'll say on the free flow left, continues left around that curve, then the potential is there for the bridge parapet or whatever to get in the way. The other challenge you run into is right now a driver that is approaching this crossing, it's heading eastbound or towards the top of your page that wants to turn left. Right now they're looking at that crossing. Whereas if I position it farther up the ramp, when they try to make the curve, they're actually looking over their right shoulder and looking for a gap. And so they're looking at the cars that are approaching them to find that gap, and they're not looking ahead at the pedestrian. So putting that crossing closer to the arterial is a lot better from a safety standpoint. Plus, that's where the speeds are probably the lowest as they're making that turn. As you push it farther up the ramp, vehicles are going to start accelerating as soon as they get out of that curve. And we also want to make sure that when they cross the free flow ramps, we make the crossings as perpendicular as possible. Shorter distance, the better, because they're vulnerable and they're very vulnerable at an unprotected crossing. So let's minimize the amount of time that they're exposed. And pedestrians, when they're crossing this free flow right turn, are particularly vulnerable because they're looking to their right, which is not their common direction to look at initially. And again, it goes back to a little bit about the unfamiliarity, potentially the signal phasing or the operations of the intersection. So sometimes it might be helpful to offer a reminder. This was actually been utilized in Utah. Is, you put a little bit of pavement tattoo at the bottom, it just tells the pedestrian, hey, look to the right. Good reminder that they can look and be like, oh yeah, I don't want to look left. If I look left, there's no cars, I'm going to step out and get hit. And then bicyclists, we'll touch on quickly 3 possible treatments at a DDI. So one is the separated bicycle lane or shared use path. One is a marked bicycle lane like you see in this image. And then one is the bicyclists share the driving lanes with the vehicular traffic. We've seen all 3 of these in different configurations. Ddi 217 says that the bicyclist sharing the driving lanes with vehicular traffic should only be used in very low speed conditions. So if you've got a very low speed DDI, then that's something you'd want to look at. Otherwise, try to give them their dedicated lane or even a buffered lane or an offset lane. And when you're handling bicyclists through a DDI, it's very similar to the way they would run through any interchange configuration, because you're still keeping them to the right of the vehicles. Okay, so it doesn't really matter when they're going through a DDI, they're still to the right of the rightmost traveled lane. And that this is going to position the bicyclists on the inside of the roadway across the freeway, but they're still right of the driver. So as long as you can convey that and understand that from a driver or from a bicyclist and a driver's perspective, they're still to the right of that vehicle as they go through the DDI. And one caution that we've seen a few times is these lengthy keyhole bicycle lanes, if you will, as you're approaching a DDI. So a lot of times what happens is you have these very long right turn lanes and you put a bicycle in between them, which in theory is the right strategy, but from a user friendliness is not great. Bicyclists don't always like to be in the middle of vehicles that are going past them on both sides at fairly high speeds, or could be. So this is one of those that makes me nervous anytime I see this. And then another concern is, well, what if you have a drop and an option lane? So let's say I've got a through right and a right lane. Now where do I put the bicyclist? Because if I put the bicyclist on the left side of that and a vehicle goes straight here at this option, now they're stuck. So because of that, that is a concern as well. And one strategy that we would recommend if you do that is maybe you shift them to a wider sidewalk along the outside as they're approaching the interchange to get them out of harm's way. So this example up here that you see is that option lane that I talked about, whereas you're approaching the crossover intersection, that right turn lane, there's a through right and a right. So if I was to put a bicycle lane in there, I would have a problem of where I put them. So in this particular case, at this location right here, let's shift them to the outside. And then as you can see, now if you follow the yellow track now follows down. It's on the outside of the interchange completely. And then I cross them across the ramp, the free flow right turn, potentially using a signal control, a pedestrian hybrid beacon, something to that effect if it's a heavy crossing. And then once they cross the ramp, then we can put them back into the roadway at the crossover intersection. So I think that's just one strategy, but those are things that you want to be mindful of. We want to make the pedestrians or the bicyclists as comfortable as possible when they're using a DDI. And if you want any more information on that, then tune back in on August 24th. We're going to get into a little bit more about multimodal accommodations then. So Dave, I think we're probably caught up on time. It looks like we got a lot of questions, which I expected. Pedestrians definitely, we talk about pedestrians through DDIs, it's definitely raised a lot of questions. Is there any that you want to target to answer?
Yeah. Can you talk a little bit about when we have piers in the center of the roadway and what you would do with pedestrians going down the center?
Yeah, I mean, that's a great, it kind of goes back a little bit to when we're looking at a DDI in the early planning stages, you need to be thinking about pedestrian accommodations early, because if it's say it's a bridge that's overhead and a DDI it's under, you need to potentially position your lanes far enough away from the bridge piers to accommodate the acceptable pedestrian access route, that width for pedestrians to go on one side of the pier or the other. And so you may end up with a little bit maybe of an offset thing where you've got their lanes are close in one direction to the bridge pier, closer than they are on the other one where you've got the sidewalk. Typically it's sight distance doesn't come into play too much with the bridge piers, because the sight distance becomes the challenge at the crossovers, which are outside the bridge area. But you do need to make sure you have the lateral width under the bridge to make sure the pedestrians can navigate successfully, especially if you've got potentially two-way pedestrian traffic like you would in the center and two wheelchairs that are going two different directions.
Okay. What about when you have very heavy pedestrian volumes? Do you still want to put them down the center in that situation?
Yes, I still believe, especially when you have heavy pedestrian volumes, because again, remember the conflicts. When you put the pedestrians on the outside, then they have to cross an additional free flow maneuver, right? That free flow left that they don't have to do when they're down the center. The other thing to think about is if I'm providing pedestrians down the center, I potentially could have a narrower footprint because I'm having only one pedestrian path instead of two. Because if I put them on the outside, I've got a pedestrian path on both sides. So there is that potential where you could potentially trade a few extra feet by putting them down the center. That's a good question, though.
Right. Any thoughts on transit accommodations at a DDI?
Yeah, there's been some discussion. There's one DDI specifically where they've got a BRT line that runs right through the heart of a DDI, where like where the sidewalk would be down the center is actually a BRT line, and then when you get to the crossover, all the traffic lights turn red and it goes through. So that is one. I think that's the only example of transit, a separate transit line running through a DDI. Otherwise, the one thing about transit is it's relying on the efficiency of the interchange itself to get through it. You don't put a stop. Typically, I wouldn't see you putting a stop, just outside of the DDI. But at least it allows you that opportunity to navigate through the DDI more efficiently.
Okay, one more question about, please comment on issues related to median light rail through the DDI.
Yeah, that was actually the one I was referring to. I think I said it was a BRT, but you're right. It's a light rail through the interchange. Yep. But that runs its own challenge just simply because are the pedestrians accommodated? I don't remember on that one if they're where they're accommodated. I thought it was just a transit line to get through the interchange, but I could be wrong. I'd have to go back and look at that one. But some of the challenges certainly if you are running it through a true light rail with a stop in the middle of the DDI, which would be very uncommon. You just have to make sure you have the right width, but you still have that challenge of getting them through the crossover intersections. Where you have to flip everybody red, and have at least the through movements have to be red. So there's going to have to be some preemption or something that transit line can do.
Okay, this is for Brian. Brian Martin. I keep getting several questions about whether the presentation will be available to people. Brian, is there an easy way to get this presentation out to everyone that's attended today? Maybe Brian's not there. We will find a way to get a PDF of the presentation out to everybody.
Yep, that's a good question.
Yeah.
All right, we're ready to move on?
Yes.
All right, let's touch on constructability now a little bit. So, and you'll notice that we're covering a lot of topics. So it's a little bit like drinking from a fire hose, but trying to give you some of the best practices as you're thinking about what implementation of a DDI looks like, all the way from planning through construction. So when we're talking about temporary traffic control, you're looking to build a DDI at an existing interchange, existing diamond interchange. There's certainly many options for maintaining traffic, and they're often very site specific. That's no different than any other project. But one recommendation that I have is that you do a full closure of the interchange for the weekend to wrap it up before you open as DDI. And the reason for that is to finalize the signal, to do the testing for the signal, to put the final pavement markings in, so that when you flip the switch as a true DDI, everything is what I'll call clean. And there's no confusion of pavement that maybe is not striped. There's temporary markings still on the ground while you're trying to get it to operate as a true DDI. So it's a recommendation I have. It's one that I've promoted. A lot of DOTs use that same strategy. Certainly it's site specific. If you can't physically do it, then there's other ways you'll have to figure out a way to finish the DDI. But it's just something that I recommend. When you look at the options for maintaining traffic while you're constructing this, certainly you've got the closure between the crossover intersections. So in this particular case, especially if you have to do a lot of bridge work, to accommodate the DDI, whether it's widening or a new bridge or something to that effect. You allow the right turns on and off the ramps, but you don't allow the through movement or the left turns. So that requires some maintenance of traffic concepts, adjacent roadways, that sort of thing to be implemented. Obviously, offline construction is needed a lot of times because you're putting in curvature, you're adding ramps that are used to be pretty much teed in that now have some curvature approaching the arterial. So maximizing the offline construction will help, and then shifting traffic to that to finish some of the traffic. That's always an option. And the most common strategy that we typically see is part width. And with part width construction, let's say it's an existing 6-lane facility, which would be, say, 2 lanes in each direction plus a left turn lane and back or side by side. There's a reason why I've got 2 lanes in each direction and a full length left turn lane. And so if I'm doing part width construction, I run into a challenge where I have half the number of lanes. So now I have to figure out, well, how am I actually going to make it work? And typically a 6-lane section, when it's broken down to 3, becomes a single lane each direction with back-to-back left turn lanes to make that 3-lane section. So I've taken my left turn lane storage, cut it in half. I've taken my number of through lanes and cut them in half. So that becomes a real issue potentially during construction. When you look at the signal timing, I still got 3 phases at the intersections, but I have half the number of lanes. So now we call this gridlock typically, because if you're to the point at an interchange where you are converting it to a DDI, there's enough traffic there that the existing diamond is already hurting. And now you're taking that existing diamond and cut it in half. So for that reason, one strategy I recommend is to operate as a DDI during construction. This was actually started, I think, in Utah. And Utah started to do this because they just were running into issues where they couldn't get good, acceptable traffic operations during construction. So what they were doing by operating as a DDI during construction is they were essentially knocking down or reducing the learning curve, because it was, while orange barrels are in place and while construction vehicles are in place, typically drivers slow down a little bit anyway. They're interested, they want to see what's going on. They're usually a little heightened aware because it's a little bit different. And so as a result, this is when Utah would start to say, all right, we're going to actually run it as a DDI during construction and take advantage of the efficiencies that DDI gives you. So now if it's an existing 4-lane facility with those left turn lanes, then when we do part width construction, now it's 2 lanes. And the 2 lanes could be 1 lane each direction, but now I don't need a dedicated left turn lane because I can have that free flow left. So the image kind of on the right is a sketch, if you will, of what it could look like. But like I said, Utah actually was saying that when they did this, they were actually seeing better traffic operations during construction than before construction, which was unheard of. So this was actually done in District 2. It's actually in the process of being done, I should say, on State Route 2 and San Pablo Road. So this strategy, and if it works as well as we expect it to there, I think this is the wave of the future. All right. So another one of the common comments that I give when we talk about constructability is understanding your proposed infrastructure and how it relates to your existing pavement. So this drawing here shows the proposed DDI schematic with the existing diamond interchange pavement shaded in yellow. So in this particular slide, all the circles that you see there are proposed signal pole foundations. So the challenge is, note the number of foundations that are in the existing pavement. That would be difficult to construct. So what would happen if we just take this signal pole, for example, this one right here, and we shifted it to the other side and we oriented the head or the mast arm? Still does the same thing, but it takes that signal pole out of the existing pavement. So now we can dig the foundations, We can get the signal poles erected and not have to wait on those signal poles or those signals to be in place. So especially when you're doing your signal plan, but even when you're doing your overhead sign foundations, that sort of thing, turn your existing pavement on at all times. And even if you have to create a drawing similar to this, where you actually shade the existing pavement, just something so you can see it. Because there's a lot of options right here with all these signal poles that are quote unquote in the way of the existing pavement, that we can move them. We can shift them around and meet the exact same needs as far as stop bar offset, that sort of thing, but get them out of the existing pavement and make it to where they are no longer the critical path for construction. Another area to touch on is pavement joints. So this obviously is when you're talking about concrete pavement, but acute angles when creating pavement joints cause issues. And here's an example. This is the yellow lines here are the pavement joints that were constructed with a concrete interchange that was done in a northern state, in Ohio. And what I want to point you to is that circle right there. This picture was taken 6 months after this project was constructed. And they already had an issue where the pavement joint came apart, the concrete came apart in that spot. And so this is the same interchange as the other crossover. Those yellow lines represent the pavement joints. And again, look at how crazy those yellow lines are. A lot of acute angles, a lot of joints that come to a point, which is going to be a very challenged maintenance issue. So Utah, back in June of 2014, put together this little drawing for a concrete pavement sample joint layout. But you'll notice even on this one, I highlighted 2 of the images in green. Those would cause problems. So this is one of those to be aware of, and things that are still, when we talk about best practice still evolving, this is one of them. This is a challenge. There's not a ton of concrete interchanges necessarily, but when you do have them, this is what you have to deal with. All right, let's get into the plan detailing here. So we talked about already these early reviews, or these reviews that Florida DOT is doing. And so as we're looking at these reviews, there's some information that is needed, and we touched on this briefly, to validate the DDI. And so that's the horizontal and vertical geometry. We need to see that. The truck turn exhibits, and again, the developmental design criteria shows you how best to accommodate truck turns, especially when you've got multiple turn lanes. The traffic analysis, because we need to be able to validate that the lane configuration, the lane usage, the fact if you have an option lane, for example, for the free flow left, do you have enough storage from the stop bar to the back of that option, or the diverge of that option lane to not lock it out? That sort of thing needs to be evaluated. And a conceptual signing plan if you have it, because that conceptual signing plan is the start of us being able to identify if can we sign it? Can we place the signs in a spot that makes sense? Are the signs accurate? Are there confusion? Hit them early, and then that way we can fine tune it as we go through the process. And we like to see it on one large roll plot schematic, if possible. I know sometimes we break them up into sheets, but if there's a way to stitch it together in one roll plot, it makes it so much easier to review, especially when showing the entire DDI on one sheet. So we got one review once that had the DDI that just happened to be a match line, and unfortunately it was right in the middle of the DDI, which made that a challenge. And I get it, sometimes you can't help it just because of the way the sheets worked out, but if that's the case, is it possible to cut an additional sheet that's literally just puts the whole DDI in one sheet, a supplemental sheet, if you will. So, and then like we touched on earlier, when you get the horizontal and vertical geometry to the reviewers, if you can give them the CAD files as well, that's very beneficial. Not just a PDF, although PDF's nice. The CAD files are very helpful for the reviewer to go back in and actually do some measurements. And then when you're thinking about the final plans for your DDI, try to reduce the duplication of information. And we'll get into this a little bit later, in September. But with the size of these crossover intersections, it becomes so much information on one particular sheet. And then if you end up showing it on multiple sheets, that becomes a little bit of a challenge, especially if you have to make a change to any of the information, because then you got to make sure you track it through the plans. So I'll show you a trick that we did on one plan set and some feedback we got from a contractor about that, but I'll show that to you in September. You want to reduce the confusion of the plan. So along those same lines, are we showing information in multiple locations? If there is information that's being shown differently at one because a change was made but not another. Plus, remember that DDIs are still fairly new. And so as a result, you don't have a ton of contractors that have ever built these. And so they may be building your DDI, maybe the first one they've ever built. So what can we do to communicate it to them better? So part of it is, especially with technology being what it is, create those proposed surfaces, especially through the crossover intersections. Because we do a lot of warping of the pavement, we got to talk a little bit about super elevation and profile adjustments and the warping of the intersection. We need to make sure that you're providing a solution that drains correctly, that can be graded, that sort of thing. So create those proposed surfaces. And like I said, we hit that pretty quick. We're going to hit that again, in September when we get into the plan detailing. And then the last section that we're going to touch on is just the public involvement and education. The biggest thing we want to do is we want to reduce the confusion by keeping it simple. Remember that the public are not typically engineers, okay, and they're not traffic analysts. So, most of the time we go to a public meeting or a stakeholder meeting with beautiful exhibits that look like this, showing a really nice top-down view of the whole interchange configuration. But the problem with this strategy is that many people see this and they're immediately confused and can be overwhelmed with what is happening. This is usually what happens with innovative solutions. So a perfect example, if let's say I'm at the exit ramp in the northbound direction, and I'm turning left, so I'm up now at that 2 left turn lanes, people will look at that and then they're confused. They're like, but look at all this stuff that's happening on this other crossover intersection, let's say over across the bridge. And my response to them is, you're probably not able to see that from the driver's perspective. You're just seeing it in the top-down view. So sometimes it's really important to just remember that while these exhibits are good to give the overview, don't rely solely on these exhibits to communicate your innovative solution. So obviously we've got different strategies for what can be done. What I like to call the dancing ants. This shows at least how the traffic moves through a DDI. It allows you to get down a little lower. I mean, this is basically a glorified VISA model rendering. This one happens to show pedestrian that's now in the middle of the interchange, so that's helpful. Kind of gives you that context for people to understand, oh, pedestrians would walk down the middle. Here's what it might look like to them. And allows you to put it on loop in the background somewhere, and they can kind of spin around the interchange. So this tool is beneficial, but the problem with this tool is it can be costly to develop. And I will argue that there really is no substitute for videos and pictures from the driver's perspective. So, the windshield tour of the interchange is a great opportunity to convince the public that what they thought was confusing or distracting on the opposite side of the interchange when they were looking at the top-down view isn't a problem because you can't see it when driving through the interchange. The beauty about these now is there's enough DDIs in existence that you can pretty much just open your laptop in a public meeting. If you're explaining to somebody and they just don't get it, open your laptop, go to YouTube, Google, DDI interchange, and you'll get all kinds of these views and these perspectives. And there's really no substitute when you show what they're looking at here what they can truly see. And, the fact that this is the left turn, but that the eastbound through movement is going at the same time, I don't think it's nearly as alarming to a driver when they're sitting here, because while that's happening past them, you could see the channelization, the intuitiveness of this left turn doesn't really bring them into conflict with that movement. So again, just something to think about with public involvement that we'll get into a little bit more in September. And with that, the only thing left to discuss really is these, we refer to these a few times, these additional DDI resources. So obviously the one on the very left, this is the developmental design criteria for DDIs, what was just put out in November. And, it's a great document to kind of summarize it. It's still a living document. We're still updating it. And we're certainly open to any revisions that need to be made as we get into the reviews and we talk to other folks. So hopefully you guys have been able to roll up your sleeves and get into it a little bit. If you have any comments, that's reach out to Dave Amato, certainly. The middle image there is a recently completed NCHRP research project, 959. This actually is going to be the DDI Informational Guide second edition that FHFA is putting out. So the image on the right is the first edition back in 2014, which we reference a lot. This middle document is, the next version. So it's seeing how much have we learned in the past 7 years. And it's a very good document, does a lot to kind of drill into a lot of those details and a lot of those things that really we weren't too sure about back in 2014. And then states have put together lessons learned documents, which has been extremely helpful. And obviously you take some of them with a grain of salt, like the one on the right's in Michigan, a little bit different context, a little bit different culture, driving culture, that sort of thing than Florida, but there's still a lot of good information. Some of these are a little outdated as well. I think the one on the very left is 2010. The one on the two on the right are 2014 and 2015. So we've got some new information still. And then, these two are also very good documents of basically those observations, experience, and the safety evaluation that I referred to earlier in the presentation. So there is some good research. I think the biggest thing to take away is, you've got some good criteria started in Florida. You're not going at it alone. There are plenty of good resources that can help guide you. And if you have any questions, don't hesitate to reach out to David or even myself, especially as you're getting into this stuff. And if you're designing a DDI in Florida, that's great because we'll get to see it as part of the review process. So with that, I guess, David, do we have any other questions that need addressed?
I think we're up to date on all the questions so far. Yeah, I really don't have anything else. If there's no other questions, I want to thank everybody for participating. And I hope everyone will join us for the remainder of the webinars in this series.
Yeah, luckily they won't be all 3 hours long, so you don't have to listen to it for that long. But they're all 1 hour shorter, more targeted sections. So the next one's in 2 weeks from today.
So with that, I guess we can end this webinar.
Terrific. David, thank you so much.
Okay, thanks everybody.